All right, so we're solving a system of equations, right? Just remember what a system looks like, because if you had something like two variable system, two equations, okay? And we're coming across a certain situation. So what is happening when you graph the system? So if you get one solution, meaning you get one answer, one xy point, what happens is what you're trying to do is find out where the lines cross. So if you graph them and you get one solution, or you solve it and get one solution, that means they just the two lines just cross at one particular xy coordinate point. Okay? So that's what's basically happening. So if you were to sketch that out, just draw two lines that are intersecting. If you get no solution, we're defining the solution as where they cross. So the only lines that don't cross are parallel lines. So you got yourself a couple of parallel lines. They do not intersect. They don't have anything in common. If you have infinitely many solutions, which means you just have an endless amount of answers, and we're defining an answer as a point in which they share or when they cross, it's if what you have is the lines are the same line and they're on top of each other. You have two of the same lines. Okay? They share all points. Okay. All right, so now we're going to do some matching. Okay, so let's go ahead and read these and we'll try to find which ones go with it. So we have a negative, strong linear association with outliers. Okay, so a negative association. So that means this is not linear. This is linear but positive, and this is also linear. Okay, so these three look negative and linear. Okay, but it says with outliers. This one doesn't have any outliers. If I was to draw a line through this, I have a pretty strong linear relationship, and everything stays fairly close to the line. So if I look at these two, I can draw a line through it. Okay, so the difference here is they say that there is a negative strong linear association with outliers. So if you look, both of these seem like outliers right here, right? And these two seem like outliers right here. I think this one's a little bit stronger. Okay, so I'm going to say this one is F. And there's a little bit of subjectivity in this. It's not a real hard rule. Okay. So number 2 says a positive, strong, non-linear association with no outliers. So if you look at this, as we go left to right, these are increasing, and it's got a nice pattern to it, but it is definitely non-linear. I'll say that's A. A positive, strong, linear association with no outliers. Okay, so this one here looks really, really strong because all the data points are pretty close to the line of best fit. Okay. A negative, weak, right? A negative, weak association with outliers. I'm going to go with E on this one, just because the data points tend to be a little bit farther from the line. A negative, strong linear association with no outliers, and that's definitely going to be C, right? Because it's negative. A positive, weak linear association with no outliers. So if you look at D here, I can draw a line through here, and not one point doesn't seem drastically farther than all the other points, but it is a pretty weak association. So here we're going to go ahead and answer that by ourselves. So there's basically some information that we need to fill out. We have this kind of set and structured for us. So you say the scatter plot is either strong or weak, negative or positive, and linear or nonlinear. All right. And then do we see any outliers, basically? Okay. So let's look at this. Let's go through this here. So we're going to list all that important information. So if I go through here and I drew a line through this, and my first question is, am I able to draw a line through that? And I would say, yeah, that I can. So this is going to be, are those pretty tight to the point? You know, in my opinion, I'd say those are pretty strong. So I would say this has a strong, negative, linear association. Okay. Right, because it's negative because it's going down as we look at it from left to right. As the x's get bigger, the y's are getting smaller. and they're pretty tight to the line, okay? And I would say no outliers, right? So looking at the next one here is, I do see a linear relationship. I could draw a line through it. But you see how tight these are to the line and how these data points are not so close to that line. So I would say that it's a weak positive linear association. Okay. And nothing really stands out any farther from any of the other points, so I would also say no outlier or outliers. Okay. So going on to the last one, and there can be some variation on some of these. So looking at this one, I think this is a linear relationship. I think it's right here if I was to kind of go off my gut, but you know, you could also kind of draw it this way, right? You have some opinion on that. So I would say this is a weak negative linear association. Okay, but I would also say that point right there doesn't really fit the data. There is an, look for my no there, huh? There is an outlier. Okay. And there is an outlier right there. All right, so let's start solving some of the systems of equations here. So we have to decide on what method we're going to use, either substitution or elimination. Typically, we prefer to use elimination unless it's set up really nicely for substitution. But here we go. So looking at this, I'm going to eliminate the y's. Okay, so I need to get opposites. So the opposites, I got a 9. I can turn a 3 into a 9. So the opposites that I'm looking for are 9y and negative 9y. Those are my opposites that I want. And I have a 9y, so that means I'm going to take this top one and multiply it by 3 so I can turn this into a negative 9. So I'm looking at negative 6x minus 9y equals negative 27, and then 9x plus 9y equals 0. There's my opposites that I created. Negative 27 divided by 3, and x equals 9. So I'm halfway there. So then I need to plug it in. I'm going to plug it into this bottom one here. So it's going to be 9 times 9 plus 9y equals 0. I get 81 plus 9y. Subtract 81 to both sides. Divide by 9. Y equals negative 9. So this has one solution, and it goes to the point 9, negative 9. Okay. Looking at the next one here. This one doesn't look too bad either way, so I'm going to go ahead and eliminate the x's here. So this is a 1, so I'm going to go for negative 2x and 2x. So I got a negative 2x, so I'm going to multiply this top one by 2. Okay. So I'll distribute that in, and I'm looking at 2x plus 12y equals negative 16. Down below, I'm going to rewrite that equation. I didn't do anything with it. And then everything adds to 0. Okay, so basically, if you're adding two things together and it comes out to 0, they're opposite. So you subtracted the same thing. So these are actually the same equation. Okay, so this has infinitely many solutions. Okay, infinitely many solutions. They're the same line. So this is the one where I graphed it. I would have got the same line. Okay. This one over here, they just cross at some particular point. Okay, and that particular point was 9, negative 9.